Hello and welcome. My name is Chuck Hansen. I'm the chairman and CEO of Electro Scan Inc. out of Sacramento, California. And I'm delighted to be here to talk about our next generation non-acoustic leak detection technology. So let's get started. I can't think of a better topic to talk about than leak detection, given the severe drought situation we have in the West and other countries worldwide. This is a topic you can see I've dedicated my life's work over the last 40 years, and it's one that I hope to share some very interesting information. If you have questions at any time during this presentation, use your question and attendee chat widget to send it to me. There's a number of ways to reach me. You can email me, chuck@electroscan.com, text me at my mobile, visit our website, and hold your phone up to the screen and contact me over WhatsApp at any time. Our agenda will be quite straightforward. Today, we'll cover a bit of an introduction to the industry. We'll talk specifically about the leak detection market. We're going to discuss why Electro Scan's Delta is a top product for environment and energy. We'll give a brief case study, and then we'll wrap up in our time. This is an important topic, how we've gone from a wealth of water to now scarcity is a non-trivial situation worldwide. We know in the Western United States the severe heat and drought conditions that we've had. And just taking a look at our reservoirs, some at 12 to 20% of their capacity. In the last couple of days, we've had over 100 new heat recordings, with temperatures in Death Valley reaching over 130 degrees. That's 54 Celsius. This season alone, California received 11 and a half inches of rain, 126-year low. In the San Francisco Bay Area, it was even worse, just getting barely 10 inches compared to its usual 25 inches of rain. And this is not just in the United States, whether we're seeing the hottest months ever in Hong Kong, New Zealand, where it's wintertime, Taiwan. So around the world, climate change is happening and the effect on our water system ever present. The big ticket solutions are out there. We can build larger reservoirs, construct desalination plants. We can create cross-country water transfers. We could even start talking about towing icebergs. The American Society of Civil Engineers has rated drinking water infrastructure a C-, with over 2.2 million miles of drinking water and water main breaks that occur 1 every 2 minutes just in the United States. We are losing over 6 billion gallons of treated water a day, 9,000 swimming pools worth. And the 3 pillars of water are the same: pressure management, leak detection, pipe repair. And the topic we're going to talk about today is leak detection. Electro Scan is proud to be a service provider in this area. Started in 2011, 100% self-funded, with over 200 customers worldwide and over 4,000 miles of water and sewer pipeline that is assessed. Environment and Leader Award is just the latest in a string of victories, not only being designated the leak detection solution of the year, but also winning one of the late rounds of the Water Dragons event in the UK market. All at the same time, we protected our technology with patents from all over the world. And to tell you how real this is, not only do we build product, but because of our uptick in training and solutions and deployments, now constructing our own California training facility where customers can come and actually get through a water loss obstacle course, one of the only ones in the United States above ground, to teach people not just how to use our technology, but how to find and quantify technology. In it, we do instruction, hands-on training, in-pipe navigation, and also showing how automatic data capture of leaks are found directly in the field. So how do we describe the leak detection market? Who are the key players? What are the technologies that have supported this through the last 150 years? Not surprising, 100 years ago, we'd be out with our listening sticks trying to listen for that hissing sound of water leaving a pipe. Unfortunately, even up to this year, the listening stick is probably one of the major ways that we still have in trying to find a leak. Reminds me of the Albert Einstein saying that the definition of insanity is doing the same thing over and over and expecting different results. We just aren't getting those in the current technology. Now, to be fair, we have experienced major improvements in how we listen for leaks, either from above ground or through noise loggers or through tethered or untethered objects. We've tried them all to listen for those leaks. The bad news is we still miss 80 to 100% of water leaks when we try and listen for them. Let me give you a quick case study. In Sacramento, a 165-mile survey was done. Only 10 leaks were detected, 7 on the distribution side, 3 on the customer side. If we look at one 9-mile area that had 613 service connections, only 1 customer leak was heard. And as we take a look at the designated flows and the total water losses that we experienced, we lost in just 1 month alone this 14%. And if we look at that for the entire city, 14% would represent 5 billion gallons of water lost in a year. Since we talk about pools, that's 400,000 swimming pools a year of lost water. So why do we have such a poor track record with listening for leaks? It's not going to be surprising. I'll go through number 10 in our David Letterman style. The number one thing is just household water usage. That could be very confusing as water is turned on and off in a system. High groundwater. If the pipe is surrounded by wet soil or even water, then we're not going to hear that hissing on the other end. We just won't be able to hear it. Pipe size and material. You see a lot of plastic here. There's a reason why we don't have tuning forks made out of plastic. Acoustic has a very difficult time traveling through this. And if we take a look at cities like Bangkok, that has 80% of plastic pipe, Taiwan in their country, a high percentage of plastic pipe, it's nearly impossible to hear any leak at all through the system. Couplings and repairs are sometimes misinterpreted as a leak when they're not. Pipes will also have different flows. We'd like to think that water just flows through naturally through each pipe. It can be quite different given any sort of buildup in the pipe, any currents that are in the pipe. This disrupts the acoustic listening devices that we have out there. Street noise. You look in the bottom right, a leaf blower. That's probably the number one enemy of any acoustic system that's out there. Trenching and bedding. When that water is leaking out, it's retained around that trench. And so that's going to additionally cover up the ability to even hear that acoustic. Air bubbles in pockets can be misinterpreted at leaks. Just judgment. Do I hear it or do I not hear it? And even recently, some AI companies have attempted to hear a leak, but with so many changes in pressures and flows and the ability of not hearing it, it's a questionable technology at best. And then our number one reason is low pressure. We notice here in this picture, as the pressure is reduced in the pipe, notice the pattern at 75. Many of our pipes are between 50 and 150 PSI. You just can't hear leaks at those levels. We find that most technologies at best give us an area of interest rather than a point of interest. And even with things like satellites, we have some companies that say we'll find a leak from satellite. Only you're not told that we need to employ other technologies to really find where X marks the spot. Sometimes cheap does work by putting in a foam ball into a system to acoustically listen to it. Here's an example with a 14,500 population city in Minneapolis. Just 16 months after it was tested and given a clean bill of health. Not only did we have one rupture, but several months after that point, had a second rupture, even worse, with both costing well over $2 million. So why is Electro Scan a top product? Why were we awarded an Environment Energy Leader Top Product Award? We appreciated hearing the comments from the judges with words like quantify, superior, stewardship, actionable. And so those are all of the things that embody this technology that we really haven't had in the past when we look at leak detection, especially using acoustic. This is not acoustic. And if you understand the basics of this picture, where we've got the circuit and we've got an electrical current in a glass of water, and we can actually see electricity moving from one side of the circuit to the other, understanding this scientific principle, then you understand how Electro Scan works. We understand that we can't hear at pressure. So let's take pressure out of the equation. Let's take things like flow or groundwater or noise out of the equation. And instead, what Electro Scan does is measure the size of the hole. After all, we're in the leak detection business. We want to measure the size of the hole of the leak. And then given whatever the pressure is in the pipe, know what each leak's gallon per minute or liters per second is. Low voltage electric current, not electromagnetic. This is electric current. And if you see in our probe and how a COMSOL model depicts how our focused current interrogates as it travels through the pipe, 360 degrees of that pipe. All we're trying to do is see if that current will leak out of any crack, bad joint, bad service connection, hole in the pipe. That's where we know we've got that leak. How much electricity? Well, you'd be surprised. It's the equivalent of 6 AA batteries, 40 milliamps in the technical term. So it truly is a low voltage, high frequency current that we're running through the pipe to evaluate leaks. So let's take a look in the field of how we implement Electro Scan. Of course, before we even come out in the field, we'll take a look at the bolt patterns for any entry point that we want to get in. So we bring the standard insertion tube that allows us to enter a pipeline without service disruption. Because we're going into a clean water system, we make sure that we're health and safety certified so we can go in. We will use the flow and a hydro chute to travel down, traverse the pipe. And our Delta actually has 3 components. We'll have acoustic, we'll have CCTV. So if we can find something with acoustic that we can, and we'll be able to travel up to 3,000 feet or a kilometer. Getting to the end, we'll collapse that hydro chute, and then the magic starts. Electro Scan's low voltage current will assess 360 degrees of the wall, and any opening, any leak, will not only locate it to within 1 centimeter, but estimate its gallons per minute or liters per second as well. We get to the end, we simply pull it out the same way that we put it in, and our assessment is over. When the scan is completed, within minutes, the data is transferred up to an Amazon Web Services cloud, where Critical H2O, our cloud application, processes all of the data, and not only will tell us the number of defects, the total amount of leakage in gallon per minute, but also every leak in the pipe, its location, closest 1 centimeter, and the severity of each leak, all in minutes, all accessible through a cloud application when we're still in the field. This is the next generation in leak detection. We all know you can't manage what you don't measure. And unfortunately, every leak detection technology before Electro Scan at best gave a position of a few meters or 10 meters or 100 meters, but never able to allow us to know where the worst leaks are. The other advantage is this technology can access the leak tightness of every joint. We may not be able to see it with the camera as it goes through the bell and spigot, or hear it if we have water on the other side, but the electric current goes directly through one end and out the other. And with cracks, whether we have cracks that are spread across the pipe or concentrated, this is all going to be critical information for what rehabilitation method that we decide we want to do. We can also use our camera to see the condition of any taps, any connections, any illegal connections, and do they leak or not? Another key advantage of Electro Scan is the fact that because it has an electric current and it's producing a signal at 800 megahertz, we can take any radio leak detection device that can pick up those frequencies, and not only do we track where that is, but we can output that into a map, so we now have a map of where that pipe is going. Another advantage is not just finding the leak, but now the stewardship of actually making sure that repairs are watertight as well. Many of you know that we have a technology out there called cured in place pipe, a trenchless technology that allows me to fix a pipe without digging and replacing. Because I cook that material inside of the pipe, the question is it watertight? Electro Scan now is the only technology, as you see here, that can tell me whether I have a liner that's in good condition, meaning no electric current gets through the line pipe, or if it's a bad CIPP, where I've actually got a leak that may sound like it's a good pipe, but where water will pass through and be spongeable. This technology is now the new polygraph test for rehabilitation. So not only identify pipes we need to repair, but now pipes that we put in the ground, make sure that they're watertight. We'll pause for a second before we go into our case study. I hope you're enjoying this so far. Your questions are coming in, so that's great. We have right now over 50 different countries on there, so hopefully you're picking that up. Again, I'm going to show my email, so if you don't get your question answered during this session, please email me. Please send me a WhatsApp, and we can talk more. Our team is licensing a number of contractors all over the world, plus we have our own crews that come in and do that work. So let's take a look at a case study that had already failed multiple hydrostatic tests. Acoustic hydrophones, listening sticks, data loggers, helium tracers, tethered acoustic sensors were all tried, couldn't hear any leaks. Pressures were erratic in this pipe. Flows were turbulent. And it was a pretty noisy construction site as well. Our crews rolled up, and within a matter of a couple of hours, found exactly the number of leaks and where they were in their intensity. We knew exactly what the bolt patterns were, so we were able to bring our insertion tube, our chlorination chamber that you see there in black, how that would protect that because this is a live site without any customer interruption. Once the project was done, data was uploaded, we found 15 leaks. The typical acoustic tethered and untethered balls average 1 leak per 3,000 feet or 1 leak per kilometer. Here, 15 in just a matter of 560 feet. But the key thing is the ability to locate where those defects are. The nice thing is we had a high resolution camera, and because we knew exactly where to look, we could see the telltale signs. For example, we saw an angular rock. Obviously, when the pipe was installed, rock got into a joint, and we could see exactly our largest leak was actually from this location, knowing where to look. But normally, we wouldn't have known that there was even a problem at this location. And unfortunately, with acoustic, our acoustic probe, it was so turbulent, every time we hit the wall, we had a false positive. We couldn't use it. Our acoustic sensor, although was a gallant effort, because every time it hit the wall, because the pipe was turbulent, we had a false positive. All of the readings were false positives. So we were in the same boat with everyone. In fact, we were asked quite a bit, why do we even have acoustic on? Well, we took acoustic off and that created our Trident system, but we like to have this British bake-off every time we go out into a pipe. Whether it's locational accuracy of 1 centimeter, determining each leak's severity in gallons per minute or liters per second, Electro Scan really has no competition in this market. The ability to not only have acoustic and electric current and CCTV in a multifaceted, multi-sensor, machine-intelligent probe. It's the first unambiguous, unbiased, unprecedented way to find a leak. To wrap up our session today, as the AWWA, the American Water Works Association M36 deploys a water balance, Electro Scan, through its inclusion in M77 for water main condition assessment, looking at water loss has never been more granular. Finding water loss before a pipe is rehabilitated or repaired, and then determining its accuracy of water tightness after repair. We've never had the ability to quantify non-revenue water like we can now. As we look at the financial benefits, they're numerous. As a leak detection company, some may argue that our largest benefit is through CapEx avoidance, knowing the pipes that don't need rehabilitation. Acoustic has never been higher in its fidelity to actually tell you with absolute confidence that a pipe has no leaks. Most of the time, we don't know. This technology provides that governance, that stewardship of knowing what pipes you don't need to fix. Because we're 100 times more accurate, the targeted leak surveys with Electro Scan is a major advantage that we have in the market. We just mentioned the reduction in non-revenue water, the ability to measure and actually have the delta, the change in gallons per minute before rehabilitation and after rehabilitation. The QA/QC of repairs. We saw what we can do with new pipes, with cured-in-place trenchless pipes, and also the ability to not only find and see illegal connections, but to measure their water tightness as well. So whether it's our award-winning Delta that can travel up to 3,000 feet in a pipe, or our Trident, a push reel system that can be pushed up to 400 feet, 120 meters into a pipe, or even our smallest versions, our swordfish, for the commercial plumbing market to get down into that 1-inch diameter pipe. So that's it. That concludes our session. Please give us a call. I welcome your questions, your comments. Dealers that are interested in marketing our product from our company, we're happy to talk to you as well. I want to thank you for your time. Whether you're seeing this live or in a pre-recorded session, there's a number of ways to reach me. You can email me, chuck@electroscan.com, text me at my mobile, visit our website, and hold your phone up to the screen and contact me over WhatsApp at any time. Thanks again, and I look forward to seeing you in the field or online.